My name is Andelkovic, and I work as an agile testing lead at King. And the reason why I'm here is because I want to share you something that I discovered 2 to 3 years ago. I stumbled upon AI on YouTube, and I went to my boss and told him, like, we need to do this. This is the future. And this presentation is a little bit the journey until today, what we have done at King when it comes to AI and testing. So normally when I present, if you have any question, just interrupt me and I'll try to answer, or we can have a discussion afterwards in this reserved area. All right, so King, do you know the company King? So it is a Swedish company founded 2003, and it produces casual games, and it has been doing over 200 games, and we were one of the first companies, I would say, that got lucky and made a successful game on mobile and Facebook when iPhone was introduced and Facebook was introduced. So what we have done since then are that we have continued to make games for mobile. That's been our main focus. And today we are around 2,000 employees, and we have 13 studios around the world where we develop mobile titles. And we have around 270 million players that play our games. I think our games has been the last 5 years in the top 10 of gross bookings, so they've been really successful. And I would say the reason why it's been successful is because the company has been working in a data-driven way. And what that means is that what we do is that we collect the data from our players, analyze that, and from the learnings from analyzing how our player plays our games, we try to tweak the game so it becomes more enjoyable for them. And the company was acquired 2016 by Activision Blizzard. I hope you know Activision Blizzard. So we have focused on, from producing 200 games, we have claimed an area, I would say, and that's the casual mobile game area. That's where we've been focusing the most. And our players are usually people that have some time when they go to and from work, or you're waiting for something, you have 5 to 10 minutes to kill. So then you usually pick up our games and play them. And the most successful title, our Candy Crush Saga. Not sure, have you heard about that game? Yes. So that some people, when I say that, they either say that yes with a big smile or with a big grin, because some people love the game and some people hate the game. So we have the both camps there. And then we have other titles that are also successful. So that's a little bit what we've been focusing on. And at King, we have different test roles that are helping out. So the way the company is structured is that we have game studios. So their main focus is to produce games. And then we have a platform team. And the main focus on the platform teams is to provide infrastructure for the games so they can focus on making good games. And an example of a platform functionality that we provide are like payments, social features, stuff like that, data collection. And so when a game studio decides to make a game, what they can do is that they can pick what type of roles do they want in their teams. So from the QA's perspective, here is a list of QA roles they can pick into the team. The teams are responsible for the quality. So it's not necessary that they need all of the roles in the team. So it depends a little bit on what they want to accomplish. But ATL, Agile Testing Lead, that's usually for teams that needs Usually when the teams become bigger, they need someone to manage the testing work. So usually they bring in a testing lead to manage that work. Also coach the developers usually in the importance of quality, that they should write unit tests, stuff like that, and fix bugs, hopefully. Then we have exploratory testers. Usually the developers are the one that are asking for those. They might have bugs that they want to, tricky bugs that they want to reproduce, or business critical functionality that they want to make sure that they get right. So then they bring in exploratory testers that helps out in hiring the quality of it. And then we have a regression test team, and what they do is that they, for a release, they run through like a test specification of like 1,000 test cases. So all of those test cases needs to pass for a release to be approved. And we do this every second week. And then we have the test automation engineers. So what they're doing is that they're building like a test automation framework that the game teams can use. So they're usually collaborating with the developers. And then we have data scientists. What they do is that they are analyzing the data. And one part of analyzing the data is to cleaning up the data. Because when we collect the data, it can be sometimes not in perfect health, because our games, you can play them in online mode and offline mode. When you play them in offline mode, we store on the device the data, and then when the device go up in the online mode, we send the data to a data warehouse, and that doesn't always work perfectly. So then you need to clean the data before you analyze the data and make business decision on that. And then we have the developers. They're in a constant learning, QA learning process, I would say. So they're getting better in understanding that they need to own the quality of the code that they produce. So Candy, our biggest game, today there are over 3,500 levels in that game, and from a QA perspective, we need to make sure that all of the levels work. So how do you do that? You can't have an army of manual testers that test each level and make sure that this level you're able to finish. So we have been thinking like, okay, we need to solve this in a scalable way. And when AI became more popular, like 3-4 years ago, that was when people started to look into this area. And what we discovered was, okay, what type of approach should we have to address this if we want to use AI for our games to try to help out. So what we did was that we broke down our game into like, okay, what's characteristics for our games? And then what we realized is, we have a simple layout of the game. We have a lot of states. You can do a lot of combinations when you play the game. And then you need to think about that the game should be, you need to think how to finish the level. It's not like that you can randomly play the level and finish. Okay, some easy levels you can do that. So you need some AI that can, in some way, have some kind of intelligence. And also, we need to find a balance where the AI are playing like a human, so it doesn't become too good or too bad. And the tricky part with humans are that we get better while playing. So how do you simulate that? So that was things that we were thinking about. What do we need? And at King, we have level designers. They create the levels. And before we used AI, what happened was that we have a level designer. He creates a level, and then we have humans that are testing the level, and then give feedback to the level designer. This was too easy or too hard, or this was a good level. And usually that could take up to a couple of days, a week, to tune that process, because the level designer, he do like a context switch. He create another level, and then he has to go back. So it's like a time-consuming process. And usually when we release the game, the level is not balanced in an optimal way, working like that. So, player simulation. Since, I don't know if you remember these two screenshots. The left one is IBM, had a chess computer that beat the world champ in chess. And it was simulating how a human plays chess in a hard-coded way. And then the left screen is the AlphaGo, one of the best players in the world. He got also beaten by a computer that was also simulating the gameplay, but more in a artificial intelligence way. So when we started to look into this, there were different approaches. So what we did was that we tried them out to see, okay, what needs do we have? So what we realized, okay, we want to have a process that are quite fast. It shouldn't take too long time. And in my world, it's on commit. I want everything to be as fast as possible. So that was the ambition level. Can we find something that are that fast? And of course, we couldn't in the beginning. So then you have to balance there. Okay, how accurate do you want your solution to be compared to how fast solution you have? So we realized that there were 4 big approaches that you can take. Heuristic approach, that's where you have like a hard-coded bot. So what you do is you just tell it, you just train it on how to complete a level as fast as possible. The good thing with doing that is you don't have to prepare that much. You can quickly get a bot like that up and running, and it's quite good at finishing a game really quick. The problem with a hard-coded bot is when you introduce new levels that have different designs, then someone needs to maintain that bot. Someone needs to recode it so it can play as fast as possible for new levels. So that becomes like it's not an optimal scalable way. It's a good approach when you want to get started quickly, just to verify something very fast. Then there's an algorithm called Monte Carlo tree search. And what this algorithm does, it goes through all combinations. So it can plan ahead what it's doing. So if you have a game board that you want to play, it's really good at simulating how it will end the gameplay. And this approach is good if you have if accuracy is really important for you. You really want to be as accurate as possible. But the downside with this process is it's quite slow. Then you need a lot of infrastructure to be able to simulate this in a fast way. When we started with this Monte Carlo tree search approach. The problem we had was that it took like days for it to train properly. So then we were thinking like, okay, this was a good start, but we can sacrifice accuracy for speed. So then deep learning was the approach that we picked, and we figured out doing this college research that okay, we have a lot of data that we collect from our users, and with a deep learning approach, what you can do, you can train an AI on existing data. So then you're like, you're like a teacher. You teach the student much faster than the student, try to figure stuff out by themselves. So we tried out that approach, and I would say that this approach are the one that we're using at the moment, because we can live with the trade-off that it's not as accurate as Monte Carlo research, but we get the advances from it being really fast. And then we have reinforcement learning approach, and this is something that we are experimenting with now. And this is more like a unsupervised approach. With this approach, you let the AI play for itself and figure out for itself what's good and bad when it plays the game. You only tell it you give it like a reward criteria. Like usually it's the score. You should try to get as high score as possible. And then it tries to figure out itself, by playing the game millions of times, how to get as a good score as possible. The good thing with this algorithm or approach are that it's unsupervised. You can just put play and let it go for itself. The negative thing with this approach is that you can't balance it to human players. That's usually what you want to do. You want to have a simulation that are correlating to the users that are playing your levels. So the good thing with this, what you can do with this approach, is that you can figure out how good would the best player get. That is what you can get out with this approach. But we are still researching this approach because it's really interesting from a scalable point of view, because it's unsupervised. So we're trying to see if we can combine that with the deep learning approach. So the deep learning approach, a traditional example of a deep learning network are when you try to train an AI to recognize cats. So what you do is that you have a bunch of pictures of cats in different positions, different types of cats, and then you encode the picture into a data format that the AI that you want to train understands, and then you tell it this is a cat. And then after doing that with a bunch of pictures of a cat, when you send in a picture of a cat it hasn't before, it's usually pretty good at predicting what type of animal, as an example, it is. So what we did was that we used the same approach on our game. And the way we did it was that we, the same way as with cats, instead of sending in a bunch of images of cats, what we did was that we sent in to the AI model the board of a level, the layout, how it looks like, and also we have recorded the actions that the players has been doing. So then tell the AI, this is a good play out. I'm not sure about, okay. So what you can do then are that you can train an AI to play a game by injecting a lot of play out data that we have collected. And the way we do that is that we break down each level. Each level can consist of over 100. We have over 100 different type of features for level, like the blue candies, the red candies, you have blockers and stuff like that. So what we do is that we take one level, and then we break that up. For each feature is a separate data layer, and then we also for a level, what we have done is that we have mapped the actions that the user can do on a level. So what you can see on the right side here is a grid, and the numbers represent, they're like edge IDs. So that represents like the action that you can take for a specific board. As an example, in this case, if you want to swap the two candies in the upper left corner, to be able to do that, what you do is that you tell the bot, you tell the AI, okay, perform action 72. What that does is that it will swap the two candies that are in those position. It will make a swap of them. So that's how we have encoded the actions into data. And what we do then are that we take the data of the board that we have encoded into data format, and then we send it into an AI training network, and we have the actions. That's the reference if it was a good or bad move that the player made. And what we do then is that we simulate this millions of times. So we trained the AI model to become good at playing the game. So what you can see here in this chart is that first you take the data, you send it in to like a convolutional neural network. That's what's used today. And what that is, it is a lot of filters that will trigger on different characteristics of the game. So what we have done then is that we have constructed a filter that are suitable for our game. In this case, we have like 11 layers where each layer consists of 35 different filters that maps to some characteristics on our game boards. And so what we do is that we send in the data into these filters, and the output is where you have 144 possible moves that you can make. So what you get out of this filter is a prediction by the AI. Which move would the player make when the board looks in a certain way? And then you can, what you can do is that you can convert that into a percentage. You use, there's like a formula called global average pooling that converts it from this filter format into a number, and then you can convert it with a softmax function into like a prediction score. That's on a high level how it works. I'm a QA guy, I'm not an AI engineer, so if you want to ask more about this later, I'm willing to take the questions. So what we have done then is that we have broken down the process how to train the AI, and then we have figuring out, the hard way we figured out, okay, what's the best approach for us to do this in a scalable way? So what we're doing then are that all of the data that we collect from our users, we store that in the Google Cloud, and we are also having AI models training infrastructure in the Google provides that functionality. So before we wrote that by ourselves, but it's much cheaper to use their infrastructure because it's built to scale. We used to have we recruited AI engineers, and their task was to train the AI, but some of them got stuck in just maintaining and building the infrastructure. So that's a learning. And also what you do is you want to make this output, the AI that you built, you want to make it in a scalable output. So what you need to do is you need to make it, you need to package it in a format where it's easy to deploy and easy to communicate with. And also a question that we had was, how does this approach map to like real players? So what you can see in this chart are each dot represent a level, and on the y-axis you have the player's success rate for that level, and on the x-axis you have the bot's success level for a specific level. And when we balance the games, we predict, okay, this is the number of moves that the player would get, or need to be able to complete the level. So what we have been doing, what you can see in this gray prediction band, that's the range of the prediction, and then you can see the fallout when you compare that to the players when they actually play the game and the bot when it play the game. And in most cases, they are within this prediction band. So that's the, for us, that was the proof that we can go ahead and trust the bot. It is playing the game in similar fashion as our players, or most of our players does. You have dots that are outside of this prediction band, and that's usually because sometimes the bot can get stuck, and then you need to that's humans can also fail. You have a bad day or stuff like that. So when we now have a bot that we trust, what do we get out of it? The good thing are now we can, when the bot is playing, we can collect even more data that we couldn't collect in an easy way that we did before. As an example, before it was really difficult to figure out, okay, what did the player do? Now we get that for free with the bot. And here's a list of examples of stuff that before it was tricky to collect that data. Now the bot are retrieving that data immediately. And this is data that are important when you try to learn, okay, is this level hard level or not? Especially like, okay, how many moves should we let the player have for this level? Is 20 enough, or do we need 25? And then we can look at, okay, the bot, how many attempts did it need in most of the cases, and we can go with that to tweak it. And to run the bot, the setup that we are doing with is that we have like a bot, and it communicates with the AI model that we've trained that are residing in the cloud. And then we have built an interface into the game so that the bot can communicate with the game also. So what happens are that the bot are asking the game, what level do you, start level 5. And then give me the board, how it looks like, and give me the possible actions that I can play on this level at this state. And then it takes that data, send it to the AI model, and the return or back, what it gets back is a prediction of which move it should make. And then the bot sends to the game, make this move. And then the game performs that move, and then you do that until you either fail or succeed level. And usually when people ask me, it's one thing to talk about it, but another thing is to see it. So when people ask me, sometimes it can become fluffy, like what is a bot? Like what is an AI model? What does it do? So here is like a short video that we have put together that are showing, what is actually happening. If you would have a computer in front of you, what would happen? So what you can see here up in the left corner, that's the agent. And what it is doing, it's starting the game, collecting the board info and available moves. And then it asks the AI model, which move should I perform? Sends it back to the game. And the game performs that action. And then it repeats that until it either complete or fail the level. And down in the left corner is like a debug window where we can step back if there's like a odd behavior. We can reproduce that behavior and try to figure out what happened. So this is how it looks like when the Candy bot are playing. So now you know how it looks like. Okay, so doing all this, what was tough and what have we learned? And the first thing is what you just saw. That's usually the easy part. The difficult part that we have been struggling with are everything around. Like, how do we collect the data? How do we set up the infrastructure? How do we analyze it? And how do we utilize the bot? So I just want to emphasize that if you're going to start something like this, be aware that, I think you should make first a decision like, should we do it ourselves or look for solutions that other could help you provide with you so you can get up to speed as fast as possible to try this out. Luckily today there are a lot of providers where this infrastructure are already available for you to use. So in my world I would go with that to try out something simple, small, and then later on if you think that you can do it better or cheaper or faster, maybe you should build it yourself. Another challenge that we had was the game was not designed to be used by a bot. So the first problem that we got was like, okay, we can't use the game how it looks like when we started. It was too slow because the bot needs to run millions of times. And the way when you have a graphical user interface, you need to take into account animations, the frame rate of the game, and that's not fast enough. And also like the computer will get overheated, and you need to slim down the iteration process of your application. So in our case, what we did was then that we spent a couple of months some AI engineers together with the game logic developers of the game. They made an interface, a REST API interface that you can access the game through the command line. And then they disconnected the game logic that were dependent on the graphic animations and other time-consuming things. And when they have done that job, then the bot could use the game in a practical manner. Then we can start to train it. And the good thing when the bot communicates with the game now is that we can retrieve the game state. So that's also important. If you're going to make an application that you're going to train on, think about you should be able to save all of the game states and replay it. That's really important from a learning perspective. So if your application can't save a state, that should be one of your first questions. How do we save state? Each action and user do to your product, how do we store that for learning purposes? And also, you need to think about platform support. Should it be like at King, people can use any platform they want to develop. So we had that problem in the beginning. You know, someone was using Linux, someone was using Mac, and we were like, okay, we need to have a agnostic approach to this. So that's also a thing to think about in the beginning. And also, when you create a bot, the thing that we had the problem in the beginning was like, okay, what data should we use? We used this Monte Carlo tree search approach in the beginning, where we didn't collect the user data and use that. And then when we realized, okay, we have a lot of data, how do we, in a practical way, how do we get a hold of that data and break it down into something that we can use? That took time also, because you need to find the right people that owns the data and align with them so that you can take the data, because they're really protective of the data. So then you need to explain what you're going to do with the data and stuff like that. So that's something to be prepared for. And also like, how should you communicate with the game? And I think the best approach is to build some kind of API, if possible. And also like, challenge was like, usually it was from the management. They were like, is this going to work? You have your bet here that the bot will be able to play as a human. So then you need to, as soon as possible, prove that with, how do you correlate that your theory with the reality? Because you get like, otherwise you can get like a trust issue if you can't prove that. And then also like, what infrastructure do you need to set up? And we realized that we needed a lot of processing power. In the beginning, we were using like an old PC, and it was like very hot when that one was, working. And so we moved over to the Google Cloud platform. So that's also one thing to think about. Yeah. How much you will need a lot of computers, and also like it's good when you have this up and running that you should be easy to deploy the bots. So you should be able to like say to it like play level X with X number of bots, and you should be able to press a button and it should just happen. That's what you're gonna. That's what you should aim for. Things that we realized after that are sharing to you that should be asked before, I would say, are who should own the bot? Who should own the AI initiative in your company? That was not clear in our case. I'm like a QA guy. They were asking like, you're a QA guy. Why are you, working with AI? And as I see it, I think in the future everyone will work with AI in some way. And so in our case, it was just, okay, we don't know who should own this. So we just agreed that, okay, start a team, and then we figure out on the way where it belongs. And I would say, I think in the future, it will belong everywhere, in all parts of the organization. We'll have some AI division or people that are responsible to look into that area or own that area. And also, like, how should you staff that? Should you use existing people or hire in people? That's a decision that you need to make, because you need the expertise in this area. You can't just start day one. Okay, what I did day one was I was looking at YouTube videos to train, to learn. It was not like a course that I could take to do this. So you need to think about that. And also this, your product, how much do you need to, tweak it to be able to use it in an AI infrastructure? That's the one thing that you need to think about. And when should you start this? And in our case, what we did was that we started with a sprint. We just dedicated a sprint. Let's try to get some kind of embryo up, and then we iterate on that. You could do it with a hack day also. What we do at King, we have these AI challenges where we invite people and we give them like a game, and then you should create like a bot to play the game as a fun competition. That could also be a good way of getting people to try this out. And then you have the maintenance. When you have this up and running, who should own to maintain this? If it's down, who should fix it so it gets back up? And if people want to contribute, who should they talk to? Stuff like that. So you need to find someone that are the go-to person for this. Or like in our case, we use Slack at our company, so we have like a separate, like a dedicated Slack channel, so people can ask questions there when they have AI-related questions. So that has been working very well. All right, so what have we gained from using the bot? I would say one thing that we realized immediately was when we were running the bot on the game logic millions of times, we were like able to find really hard crashes that are where you have timing issues between different components of the game logic. So you get that for free. You get like tough testing immediately when you run the bot on your game logic. So that was a really like for free thing that we got. And also the bot, it's running all the time. So you're testing your code all the time. So you get that for free also. So that helps out to iron out bugs earlier, and also like this. Sometimes you can catch bugs late in the process. You can reduce that by having something that are testing the code all the time. The content, because we can, the bot are much faster than humans in figuring out if a level is good or bad. We can tweak the level more times and much earlier. So we tweak more than we did before with the bot, because we get the feedback much faster if a level is good or bad. So what has happened is that the quality of the levels have gone up. Players are more engaged when they play the levels because they're more balanced and they're not too difficult and not too easy. They're more like on a challenging level that they're happy with. So you get that also for running this feedback loop much faster. And also the feedback before could take up to a week to get like a feedback if a level was good or bad. Now it takes a couple of minutes. So the level designer, he can sit there and tweak the level one time, and then it's pretty accurate to what we're going to release. And so he can focus. So the level designers can focus on creating more levels and also making the levels more fun, because they have more time now to make the games more fun. Usually, the problem are they're running out of time, so they have a limited amount of time to make the game as fun as possible. Now they have more time to do that, so the levels become more fun and more creative. So that's also one thing that has happened. And also, because we're now using the player data, we learn more about the levels and also the players' behaviors. And also, when we create the levels, we are using more metrics to balance the games. So the games are more balanced, and that's also like something that we that are really, really important. That collect data, as much data that makes sense for you, and analyze that multiple times. That's something that I would recommend you. That's something that we have got out of this. That's really good. Yes, and if you want to know more about this, you can talk to me outside. I guess these presentations are going to be shared. And here's like links to papers that we have written while doing this work. So if you want to dive down into this, so that you can find this on the internet and download. And yeah, questions? Yes? Yeah, he's coming.
First of all, thank you for your presentation. Do you had such? Do you had such issue? For example, bot says the level is perfect. I passed it about 1 million times, but when you release it and your user says, no, we can. No, we can play this level. It's very difficult. We don't understand how to pass it.
Yes, of course we have.
What did you do with it?
Yes, we have cases like that. The bot, I would say, fail, but there are less fails now than before. So for us, of course, now it's easier to analyze why it failed, so we can, fix the fails much faster. I don't think we will have a fail, at least not in a foreseeable future. We will not have like a fail-safe, situation. But if we can reduce the number of fails, and now we have a tool to address that. Before it was really, it was much more difficult. It was like really unpractical because there's so much data, and we didn't, you can't use. We have a lot of data analysts at King, but you can't have like every company can't have like hundreds of data analysts to do this work. So this is the scalable way to do the approach to address this, I would say. Thanks. Yes. Okay, who? Okay, he has the microphone. Yes.
Thank you. I have a question.
Yeah.
Did you try to use this AI not for QA, but to design the levels of a game?
Yes, we have done that, a project like that. I think we have published a paper about that also, and I think the outcome of that was that in our case we needed to prioritize. We have limited amount of AI engineers, so what was more important? Was it to research that area or help the games with what we have learned so far? So what we have done now is that we have put that on hold, and we will look into that when we have distributed the AI bots to the games. But we have started to look into that area, and that's also like an area that are really developing. I'm monitoring what's happening in the AI scene, and I would say the last year, the content creation part where AI helps out create content has exploded. So I think that's definitely an area where AI, I think, have a promising future. So if you're working with something where you create something manually, I think you should, immediately Google, what you're doing plus AI and see what's happening in that area. Okay. Yes.
How did your playtesters' routine change after the introduction of the bot? Have you found new tasks for them, or did they just have more time to play?
Yeah, so what has happened are that we use less humans for the playtest, and then they can do other work. Like, so what I think will happen, I think in the future, at least the QA, I think, of course, what is happening with the QA discipline, I think, in the future, we will be the teachers of the AI. We will train it how to test. We are having a project now at King time, running, where we're trying to build a QA bot that thinks like a tester. And to do that, I've been interviewing our testers, like, okay, how do you think? It's not an easy, you get strange answers to that question. So I think in the future, QA people, and I think all disciplines will be teachers to the AI. We will do like a brain dump. This is how we're thinking. I was happy today, so I was thinking like this. And I think that will happen more and more moving forward.
Hi.
Oh, there.
Hi.
Yeah.
Thank you for the presentation. I understand how you use AI in game industry, but what about other industries? Like if we are doing internet or fintech or anything different, how AI can be used there? Maybe you know or have advice?
Yes, I have a super simple answer to that question. If you have data, or if you can collect data, I think you need like 2 or 3 metrics. If you can collect 2 or 3 metrics from whatever product or solution that you're working, then you have enough input to train an AI to do something much faster than a human would do. Now this is like a broad statement, but in general. So like an example then, the Internet of Things. Let's say that you have a solution where you have a sensor that are, I don't know, measuring temperature in your bathroom. So it might take into consideration time, humidity, temperature. That's 3 parameters. So you could probably train an AI. How should we regulate the temperature in the bathroom? Depending on the people that live there, how they use the bathroom. So it might, lower the temperature when they're not there, start to higher it up an hour before, normally when people use. So that's maybe like a rough example of how we could, utilize AI.
I understand how to utilize AI in different areas, but with respect to QA industry, because we're in a conference for QA, so how we can use the same technique in testing other projects, like internet shop, for example?
Yes, what you could do then, or that you could build like an AI bot that are an expert in shopping on the internet. And the way you do that, you train it to shop on all shops on the internet, so it becomes perfect shopper. And then you just balance it by train it on the shopping data that your shop, the user, the top 100 or 1,000 users that are using your shop, you can use them as a reference of, okay, we want the bot to, we want to tweak our shop so everyone shops like they do. So that's like an example how we could,
Will it be AI? It will be, I just select 1,000 representative orders, which I think, and that's all.
Well, I think ideally you would like to do that in an unsupervised way. You don't want to have like a lot of people doing that. That should happen in real time. And I think like Amazon are doing that now. They're like analyzing people when they are doing purchases, and I think they can monitor where people are going with the cursor and stuff like that, and then they're like adjusting in real time, suggest recommendation offers and stuff like that. So it's already happening.
Okay, thank you.
Thanks.
Ручки. Смотрю, куда, кому. Ага. Сразу 2.
Hello.
Hello.
Thank you for presentation.
Thank you.
I have a question about is there a point when you have to stop to feed your intelligence with new data? Then you think that there is no data, what have you feed to your deep learning machine to know something new?
As I see it, you can do it in two ways. Either you have a time limit. Okay, we will just train it for 24 hours, and then we see how good it gets in that. And then we tweak the training process, so it will be able to finish that. Or you have maybe, okay, we will train it until it's reach a certain goal, so a certain training, a certain intelligence level. What you can do is use time as a, I would say, like a factor. You could also like synthesize data. That's another approach. So you can create data. If you don't have enough data, there are like, I think there are like a lot of companies now that provide that solution. So you could like create, fake cats instead of, do like a Google search for, 1 million pictures of cats. So I think that's, I would say 2 ways to address that.
Okay, thanks.
Yes.
Hello and thanks. And a question about how are you using supervised learning when you develop not new levels, but new game features? Because as I saw in your network architecture, you had a feature levels for different gems. I don't know, do you have a? So what if you want to add a new type? Do you design a new network? And where do you get the data to train this network? For example, do you use the other approaches like heuristics to feed the new data about new game features, or?
Okay, so the answer to that question, or I'm not an AI engineer, but what I know are that they're constantly making different versions of the bot. So they don't have one AI model, they have multiple AI models. And I think now they're experimenting in a way of how to merge them. So you train one bot on one feature, and then you train another bot on another feature, and then you merge them so that you have a new merged AI model that knows how to play both features. Then you can address this situation where we get a new feature that this bot doesn't understand. You don't want to retrain it from the beginning. You just want to merge training on how to, play this feature, and then you want to merge it with the existing knowledge how to play their, old features. So I think that's the approach that we're using now.
Yeah, but if it's a new feature and you don't have the data on the players yet, how do we play it?
In our case, it's super simple. We do play tests. So what we do is that we do like a reduce release. So normally we pick a country and then we release a new version of the game. And then we can get a lot of data quite quick because we have so many users. So in our case, we have that's not a problem for us. But in other cases, I think this approach, maybe synthesizing data or purchasing data or simulating the data, I think that's the ways to do it today. Maybe in the future, there will be like AI models that, you can just tell it, I need this type of data, and then it, can create that in, an automatic way.
Okay, thank you.
Thanks.
Видел еще здесь где-то вот молодой человек тянул очень давно, поэтому чувствую, что должен ему микрофон.
Thank you for your presentation. I was wondering, do you think that there is a risk that certain kinds of fringe players might lose interest in the game that was pre-tested by a bot? Because there might be, the game might be cleaned up in a way, be bereft from a certain kind of bug incentive that these players were looking for?
I think the boring answer are that they're probably not the majority of the players. So from a business perspective, it's like a margin. But from a game player, perspective, of course, you would like to address that also. And at the moment, I don't think we're doing anything about that. But of course, I think in the future that would be like, a group, like an area that you would like to look into to optimize, the gameplay.
Thank you.
Thanks.
Thank you. My question probably also more to a engineer, but for example, you release some level, and then bot and human not the same, fortunately or not, but player performs some unexpected action. How and do you train your bot to exclude such situation in future? Thank you.
I think we train, on different aspects of the players. We have different learnings from when the player do like a play out. And then, for us, it's also like early days. So now in the beginning, we are focused on the level difficulty. But there might be other aspects to the gameplay that we might want to take into considerations in our creation process. And I just can say that it's too early. Now we just took the low-hanging fruit. Level difficulty is the easy thing to train a bot at the moment. But there are other factors moving on forward where that's other areas that we we have this roadmap of areas that we need to address. So I would say that probably we in the future we will address that. Thanks. Over there.
It looks like we have time only for one last question here.
Thank you so much. It was very interesting. I would like to ask, have you ever found out major bugs in the bot training, and if yes, what did you do with that data, and did it have any impact?
The thing that we have detected are like crashes, crashes that are like it would be impossible for human to find those crashes. That's the thing that we have discovered while doing this, and the action we took was that we realized, wow, if the bot can detect this type of serious crash, what do we do? Yeah, just run 1,000 bots, to try to provoke more of those crashes. And the good thing with that is also that then the game logic developers, they're realizing that, wow, there's someone looking at my code. It's really difficult for a QA person to dive down deep and test the game logic, the core functionality of that. But now they're feeling a little bit of heat, the game logic developers, when they realize, wow, a lot of crashes when you look where they originate from, the core of the game logic. So they've been, I think they're shaped up their game because of that. So that's I think a good outcome. And they're more humble today also, we can talk to them as a QA person. Before they were like, oh, I'm too busy, writing this logic. Now they're more like, oh, okay, what type of crash do we have today?